Welcome back to the second video in our series on mixing C++ and Rust. If you missed the introductory video where we explain why you would even want to mix C++ and Rust, we'll link it in the video description, so go check that out. Today, we'll get hands-on and create our first mixed Rust and C++ application. For this, we will use an awesome library called CXX that has been developed by David Tolnay. CXX allows us to easily mix Rust and C++ in a safe way. The goal for today is to create a simple Hello World application that uses both programming languages. Compared to a normal Hello World application, we will use C++ for printing and Rust to provide messages that we can then even translate, and that C++ will print out. For this to work, we will first need to create a new Rust crate, then define our Rust types, define our C++ types, and then we can use CXX to bridge C++ and Rust together. Finally, we'll configure the build system to compile and link our C++ and Rust code together. So, let's head right in and join us on the terminal. First of all, let's go ahead and create a new project. For this, we'll use Cargo, which is Rust's package manager. And creating a new project with Cargo is actually really easy. We just use Cargo's new command and give it a name. Cargo will then create a new binary crate for us, which is exactly what we want. I will then enter the directory that Cargo has created for us. Now let's head into our editor. And first of all, we'll make sure that the Cargo project is configured correctly. For this, I'll edit the Cargo toml file, which already contains the name of our crate, the version of the crate, and the Rust edition we want to use for this project. First off, we'll set up our dependencies. In this case, as we're using the CXX library, this is of course the CXX crate. However, we'll also need a build dependency, and I'll explain what exactly this does later. And this build dependency is also part of CXX, and it's called CXX build. That will allow us to later configure our project to also compile our C++ code. Next up, let's get into writing our Rust code. For this, we'll enter our source folder and then our main.rs file. We now want to add two new types. First of all will be the greeting that we actually want to print using C++. For now, let's go with two simple messages, hello world and bye. Now, I mentioned previously that we will also want to be able to translate that greeting. To be able to translate the greeting, we will need to be able to choose which language we want it to be translated to. For this, we will create a type that we will be using from both C++ and Rust. So, in order to do this, we will create a new module called FFI, which stands for Foreign Function Interface. So this is just the way of saying we will interface with another programming language, and within that FFI module, we will add our enum that defines which languages we have. For now, let's first go with English, of course, but then as I am a German native, let's maybe also add German to the mix, and I've had a little bit of French in high school, so why not add that too? Now that we've defined our types, we also want to be able to actually translate using these types and to generate the correct string for printing. For this, we will go ahead and first of all import our language type from our FFI, and then we will implement a function on the greeting that translates the greeting. And of course, this function will just return a string. Of course, when translating a greeting or any other message, in a real application you would probably load some kind of translation files and do some kind of dynamic lookup, but for now it's just easier to simply add a match with all the different statements in there and all the different translations. So let me just go right ahead and add this, and I'll just speed this up in post. So what I've done here now is to simply match over all possible greetings and all possible languages and create the appropriate translation for each one. As I said, this is probably not code you would want to use in a production system, but for a Hello World demo, it's good enough. Okay, so now we have most of our Rust code in order. Let's head over to the C++ side of things. For this, we will actually first create a header file. So let's add an include directory. And inside that include directory, we will add a greeter.h header file. Inside of this header file, we will now declare a C++ class that will be responsible for printing our new messages that are generated by Rust. First of all, let's include some standard headers and then create our class. Let me first show you something on line 6 here. I've actually forward declared that class greeting. This is that exact enum that we had in Rust. So I've now already declared a Rust type in C++. For now, of course, C++ will just believe that this type exists if I forward declare it, but this is actually just the way it will work out in the end. Our greeting will actually just end up as a C++ class. So as long as we forward declare it correctly, we can just use it in our definition and declaration. So let's fill in our greeter class. Okay, as you can see here, our greeter class now just has a default constructor and a method greet, where that greet method actually just takes our greeting by reference. So this behaves just like any normal class. You don't have to deal with any pointers or anything as you would through a CABI, for example. And we can use it just as if it were a normal type. However, there's a bit of a special case here. We will also need to add a method outside of the class to actually instantiate it. I will go into detail on why that is later, but for now, let's just create a new method with which we can create an instance of our greeter. And this can simply return a unique pointer, which will make memory management for us a lot easier down the line. Now that we've declared our class greeter, we still need to actually implement it. So let's go ahead and add an accompanying source file for our header. For this, we'll go back into our source directory where our Rust code lives as well, and add a CPP file for our greeter. First off, of course, we need to include our greeter's header file. Of course, we could do this with a relative include path, but let's actually go ahead and use the canonical way that CXX allows us to do. And the way this works is CXX will expose the whole directory of your crate if you just include from the prefix of your crate's name. So in this case, we named our crate CXX Basics, so as we can include any file that is inside our crate's directory by just going CXX Basics and then the path to our file. So in this case, our include and greeter.h. And we can even already set up the include path for our Rust code that we will later export with CXX. This works basically the same way. We just use the CXX basics prefix again, and then select the path to our main.rs file, and then just add a .h suffix, as that's exactly the path that CXX will generate our header files into. So just remember, it's the path of your Rust code with a .h suffix. And this will allow us to get both the declaration from our greeter, but also from all of the Rust code. So in this case, our greeting, and more importantly, our language. As we want to be able to print something, we of course also need to include C++'s IOStream standard library file. Then we can start adding the implementation to our greet function. So what I've added here is just a very simple line that, first of all, translates our greeting, in this case into English, and then takes the result and creates a std string out of that. This is important because the translation function of our greeting actually returns a Rust string, not a C++ string. So in this case, we need to actually convert it. And this is simple enough in this case by just passing it to the std_string constructor. Now we can also use all of the different languages so that we simply print out our greeting in every language. So let's go ahead and do that. So now I just have all of the 3 languages printing. As you can see, the language type here just ends up being a normal C++ enum. I'll show you how to set that up correctly in a minute. But for now, just remember that these types can just be used as normal C++ types. We can take our greeting just by reference, call functions on it, and then for these enum types, we can even use their different variants to get access to what we need. We also still need to implement our creation function, so let me just go ahead and do that. And that's it. We now have our C++ code correctly configured and set up so that we can create a greeter, we can pass greetings to it, and the greeter will print it out, in this case in all 3 languages, but we could of course also set it up so that we can choose the language from the Rust side. Now that we've implemented code in C++ and Rust, we can start using CXX to actually bridge the gap between both languages. The way CXX works is that we need to describe the interface between both languages. The interface actually works similarly to a C++ header file, but can declare types from both C++ and Rust. Everything that we declare inside this interface will then be made available by CXX in both languages. We actually write this interface in the form of a Rust module that we then tag with the special CXX bridge macro. Under the hood, CXX will read our module and generate an appropriate C++ header file, as well as a .cpp file that will check the correctness of all our declarations. On the Rust side, the CXX bridge macro will also expand our module to generate bindings to the C++ code by automatically wrapping everything in a normal extern C interface. So in the end, this actually still boils down to a C ABI, but this is all done automatically and safely for us by CXX. Let's go ahead and add the bridge attribute to our FFI module to get started. To add our CXX bridge macro, let's head back over into our Rust code. In this case, of course, into our main.rs file. And right here, we already declared our FFI module, and this can be named whatever you want, but it just needs to be a module description that is embedded into just a normal Rust file. And right on top of that mod FFI, we'll just add the CXX bridge attribute. Now, if I save this, you will actually notice that now we get an error message down below where we translate our greeting. The reason for this is that CXX has now converted our language enum right here into an enum, or rather a type, that is compatible with a C++ enum. This is the enum that we used in the C++ code to translate into all the 3 different languages. And whilst the representation of enums in Rust and C++ is almost the same, there's a very slight difference. In Rust, only the variants that you declare in the enum are valid values. Everything else is undefined behavior. This is not the same in C++. In C++, an enum language, which has 3 variants, may actually, at the end, have any integer value underneath without it being undefined behavior. And because this is the case, CXX will actually reproduce that behavior on the Rust side of things. So this will be exported as a normal enum in C++, but as a Rust struct instead that is wrapping an integer with associated constants for each of the enum variants. And that is exactly why our compiler is now complaining that we didn't produce an entirely exhaustive pattern in our match. Because now C++ may legally create a language that doesn't exist in our Rust enum or even in the C++ enum. And for C++, that is okay, or at least it's not undefined behavior. But now on the Rust side, we also need to deal with this. And of course, the Rust compiler will tell us that we've missed something to match. So in this case, let's just, tell our translator that this is not something you're supposed to do and it shouldn't really happen. Of course, in a real application, you would probably do some kind of error handling here. But this is just one of the ways Rust is more safe than C++ because it will actually enforce you to check for parts of your application that aren't valid and to really provide a match for every possible variant. That now covers our language type. And the cool thing about this type is because we added it to our bridge, it will be a type that we can just easily use from both C++ and Rust. You've already seen how in C++ we can just use all of the enum variants as if it were a normal C++ enum. And this is not limited to enums. You can do the same with structs. So for example, I could add a small struct right within our FFI module. And this struct would then also be available to both Rust and C++. This is what we call a trivial type in CXX. And trivial types are just types that can be used just like normal structs in both Rust and C++. This is, however, limited to structs that are only made up of types that are themselves trivial. And this basically includes normal integer types, the Rust string type, unique pointer, shared pointer, and a few others that you can look up in the CXX documentation. And you can't just add any Rust type into such a struct, but for more basic types, this is definitely doable. But for our example, we actually don't need such a struct, so let me just remove this again. What we do need is to export our C++ greeter class back into Rust so that we can later instantiate it. For this, CXX adds the extern C++ compared to extern C that we know from normal Rust features. And let's go ahead and start using that. What you'll notice here is that I've declared this extern C++ block as unsafe. This does not mean that what we declare in this block will be unsafe to use, but it rather means that this declaration is in itself sort of unsafe. CXX needs to implicitly trust that the functions we're wrapping are safe to use. And for any well-designed C++ API, this will be the case. And for the most part, we can just go ahead and redeclare our C++ types and classes here. So let's start by actually including our C++ header file so that CXX can pick up the types that we've declared. For this, we can use the include macro that comes with CXX. It is important here to note that this include macro is not the Rust standard include macro. This does not have anything to do with the include macro that's in the Rust standard library. This is very, very much similar to a hashtag include in C++. So just keep that in mind. So this will now mean that the code CXX generates will have access to our to our declaration of the greeter class, and we can then import that greeter class into Rust. And that is very simply done by simply creating a type called greeter. Once we've done that, we will be able to use the type in Rust. However, the type will be what's called opaque. So that basically means Rust will know the type exists. It will be able to interact with it, but what it will not be able to do is to take it by value. This type is a C++ type and needs to live in C++ managed memory. Rust, however, can still have ownership of it by using indirections like a unique pointer, for example. Then our greeter class also includes a method, in this case greet, which we will also be importing into Rust. And here, this is actually rather simple to do. We simply use self with a colon and then the type that our function lives on, and it will import this as a member function. If for the self type, we just use a normal reference, that will mean it's a const member function. If we use a mutable reference or a pinned mutable reference, it will be exported as a normal member function. And we also actually declared that make greeting function, so let's also import that. So here we simply return a unique pointer, which CXX already understands and is just wrapped by that unique pointer type that you see here. One thing to keep in mind here is that Rust actually has a very specific convention for how to name methods, and that is to use snake case naming. However, that's not actually the case in many C++ libraries that use camel case like we did here. And what's really cool about CXX is that you can actually rename both types and functions both in Rust and in C++. So here we've just declared the C++ function, and we can change its name by adding an attribute. In this case, we want to change the Rust name, so we will add the Rust name attribute. And that way, our function will be properly named in Rust by using a snake case name. Now, you've probably already noticed that our greeting type is apparently unsupported here, even though it's clearly declared in Rust. That is because CXX doesn't yet know about it and hasn't yet exported it to C++. Let's go ahead and do that. Like CXX adds extern C++, it also adds extern Rust, which at first may seem a bit odd because we're in Rust. Why do we need to declare something as extern Rust? This is because this declaration does not just declare what we'll be able to use in Rust, but it will also declare what we'll be able to use in C++. So think of extern Rust as really being something for the C++ side of your bridge. Now this extern Rust block actually works very, very similar to our extern C++ block. First of all, to export a type, we simply add our type. It's important here to keep in mind that this type needs to live right outside our FFI module, and this is definitely the case here. You'll also notice that this type is actually an enum, not a struct, but again, this will be an opaque type. In this case, the type will be an opaque Rust type, meaning that it will live in Rust managed memory, and C++ won't be able to access it by value. And that also means C++ won't know any of the internals, so it doesn't actually matter whether it's an enum or a struct. And then we also need to tell C++ that we'll have the translate function available on that type. And that's it. We now have our translate function available. As long as the syntax matches, CXX will pick up the appropriate method and export it to C++ as a member function of that class, which we've already seen how to use from the C++ side. Now we just need to add the last bits and pieces to this Rust file, and then we can move on to building our code. You probably already noticed that Cargo actually already created a Hello World app in our main function, but we of course want to use our own. So first of all, let's instantiate our greeter from C++. Oh, and I've also just noticed that I've actually given this the wrong name. So let's correct this up here. It's not make greeting, it's make greeter. And then also, of course, we need to correct the Rust name as well. And then it should pick it up. Yes, perfect. And now this is make greeter. Now that we've created a greeter, we can then call the member functions on it. In this case, we want to greet. And because we, in C++, take the greetings by const reference, which is kind of the normal thing to do in C++, we also need to do the same in Rust, and the equivalent there is to just give it a normal reference. The last step to do now is to configure our build system so that we actually compile the C++ code and the Rust code into the same application. Now, remember when in the Cargo toml, we added that build dependency. This is now where this will come into play. A build dependency is something that Cargo uses before it actually builds your crate, it allows you to run a small piece of code called a build script that can configure your build, that can link in new files, and in this case even compile C++ code for you. And CXX build is one dependency that we will use within that build script that will expand our bridges to valid C++ code and then compile that C++ code for us. And to set that up, we need to, first of all, create that build script. So in the main directory of your crate, create a file called build.rs. Cargo will then automatically pick up that this file is your build script. And this also needs a main function that Cargo will run before actually building your Rust code. And here we then want to use CXX build, and we will tell it where to find our CXX bridge. So in this case, this is in our source/main.rs file. What this does is it will generate the appropriate C++ code for that bridge. And it will also configure the C++ compiler to compile and link all of the necessary files. The return value of this bridge function will then be a reference to that C++ compiler that is wrapped by the cc build crate, which is the standard crate to build C and C++ code using the Rust build system. And one of the functions we can call on this cc builder is file, which will simply include a new file, in this case a C++ or C file, into the builder that will be also compiled and linked into our application. And in this case, will be our greeter.cpp, which we manually wrote and which CXX doesn't yet know about. So we will simply add that to our compilation as well, and you could add any C++ code here you want. Then we'll tell CXX build to compile, and for that we will need to give it a name for our library. Usually you can just use the name of your crate. In addition, we'll also tell Cargo, which is Rust's package manager and build system, to rerun this build script if any of the involved files change. And that's it. Our build script is nice and simple and includes everything we need to do to both generate our CXX bridge and include the appropriate C++ code and link everything together. And now we can simply use cargo run to run our application. No, and now we can actually see that I've apparently had another issue somewhere, and you can kind of also see how it will look like if you have an issue, in this case in our C++ code. And what this error message is telling me here is that I forgot to add the const keyword in my definition of the greet function, which is a const function, but I forgot to add that in the CPP file. So let's go into our CPP file and add the missing const. Now let's try running it again. And there we go. We get both hello world and our bye message in 3 different languages, translated by Rust and printed in C++ using standard cout. With our hello world application, we've now seen a fair bit of what CXX has to offer. We used our FFI module to describe the interface between Rust and C++. The build script then generates all the necessary C++ code and links it to our Rust app. CXX's bridge macro expands on the Rust side and interfaces with that generated C++ code. This results in Rust and C++ types that can almost interact as if they were native in both languages. We can even rename functions and types to adhere to the conventions of both languages, which I personally think is a really cool feature. There are a few restrictions to keep in mind when working with CXX though. First of all, opaque types are only accessible by value in the language they originate from. CXX, however, also allows you to declare shared types that don't have this restriction, but not all types can be shared. Also, shared enums aren't actually enums in Rust. They behave almost the same, but can contain any integer, so we need to remember to add a wildcard pattern when matching. In my opinion, this still leaves us with a pretty clean application that uses both languages together. For more details on CXX, check out the CXX book and documentation that we have linked in the description. Also, make sure to subscribe and ring the bell so you don't miss our upcoming videos where we will expand on our knowledge of CXX to add a graphical user interface to our app. For this, we will use the CXX-Qt library that we at KDAB are developing. Bye und bis zum nächsten Mal.